Hey everyone, this is Abby. I just wanted to go over the problems in the 13th recitation worksheet that we did this past Tuesday, just to clear up any remaining questions or confusion that anybody might have. So let's just get right into it. Question 1 is asking to draw the two possible structures that could exist with this square planar platinum bonded to two amine groups and two chlorine groups. And so we know from the question that there's only two possible structures. We also know that the central square planar atom is platinum. So we can start by drawing that platinum center. And then we know it's a square planar geometry, so it has to have four bonds, and they're all going to be in the plane of this whiteboard that I'm writing on. So imagine they're all sort of flat on this page. And then we're going to start drawing in the groups that are bonded to it. So we have two NH3 groups and two Cl groups. And so one possible way to attach those to the platinum center is with the chlorine atoms adjacent to each other or next to each other. And that also puts the NH3 groups next to each other. And so you might have noticed that I drew this one kind of funny because you'll learn in some of your more advanced chemistry classes that this nitrogen atom is the one that's bonded to the platinum, and all of the hydrogens are bonded to the nitrogen. But that's kind of irrelevant for now, but I just wanted to explain why I drew it that way. So that's one of the ways to draw this molecule, where we have each of the like groups next to each other. Now the other possible way to draw it is to have each of the like groups opposite each other. So we'll put the chlorines on top and bottom and the amine groups on the left and the right. And it doesn't matter whether I put the chlorines on the top and the bottom or the amine groups on the top and the bottom, because all of these molecules, as long as we don't break any bonds, we can freely rotate these molecules in space. So I could turn this whole thing 90 degrees, and that would put the chlorines on the left and the right and the amine groups on the top and the bottom. So this is totally just arbitrary, but we can rotate it in three-dimensional space. So I just wanted to sort of explain that a little bit. So that's question 1. Question 2 is asking to label each of these structures and say which one is the cis platinum and which one is the trans platinum. And then it also gives us that cis means this side of, or next to, or adjacent, and trans means the other side of, or opposite. And so since we only have two different types of groups attached to the central platinum atom, we can look at either one of them, because on this left molecule, we have the two chlorines adjacent and the two amine groups adjacent. And then the opposite is true here. We have the two chlorines opposite each other and the two amine groups opposite each other on the right. And so we can assign this left one as the cis structure because they're adjacent, they're on the same side as each other. And then the right structure as the trans one. And so another word for these two structures is isomers. So that would mean that this is the cis isomer on the left and this is the trans isomer on the right. And that's just sort of a fancy chemistry word that means similar structures, just different connectivities. So that's question 2. And then I also just wanted to make a quick note that here it mentions configurational isomers, which you might not be familiar with, but your textbook calls it geometric isomers. So that's the same thing here. Configurational isomers and geometric isomers are the same thing. So we can go down to question number 3, which says, are the cis and trans platinum mirror images of each other? So we can go back up to question 1 where I drew these, and I'm just going to get rid of some of this extra stuff. So are they mirror images of each other? So we're just going to draw in an arbitrary mirror plane here. And we're going to see, are all of the atoms reflected in the appropriate position across this central mirror plane? So the top atom on the left is a chlorine, and on the right, it's also a chlorine. So that's a pretty good start. We have platinum in the middle on both sides. And then the furthest group away from the mirror plane is an amine group. And the same thing is on the right. So we have a pretty good start. However, we start to look at the groups that are closest to the mirror plane on the left and the right, and on the bottom of the structure to the left and the right. And we find that they're opposite each other. And there's no way that we can rotate either of these whole molecules to match the one on the left here without breaking bonds. And we don't want to do that because then we're creating a different structure. So if we're going to answer question number 3, that would be no, they're not mirror images of each other because we can't rotate or move them around without breaking bonds to make them identical on the left and the right. And so then we can also look for superimposable images for these two structures in question number 4. So to do that, superimposable just means that you can completely overlap each of the structures and all of the groups match up to each other. And so I'm just going to grab this whole thing and move it. And so what we see, and I'll just sort of move it a little bit so that you can see each of the groups. The chlorine on the top and the platinum in the middle overlap, as well as the amine groups on the left also overlap. But again, we have this chlorine on the bottom and the amine group on the right that don't match up with the ones on the left. And so if we go back to question number 4, that would be also a no. They're not superimposable images onto each other. So, so that's it for the square planar models. Now we're going to get a little bit more complicated in question number 5, and we're going to draw them as tetrahedral models. And so to do this, we're going to take that central molecule, and it says use a tetrahedral carbon center, and I'm just going to fill that in as a purple sphere for simplicity. And I'm going to start to draw in some bonds. And for a tetrahedral model, at least one or two of the bonds is going to be in the same plane as the central atom here. And then one of them is going to be represented as a wedge because it's coming out of the board that we're drawing on. And then one of them is going to go behind. And so that's going to be represented as a dashed wedge. So then we can start drawing in those same chlorine and amine groups. And so we're going to start with this cis isomer. We're going to have a chlorine and a chlorine next to each other. And then we're going to have an amine and an amine next to each other. So that is our cis isomer. And then we're going to try and draw the trans isomer. And question 5 is asking if they're mirror images of each other. So we're just going to start drawing the form of the structure to mimic the one on the left. So we're going to draw the two in-plane atoms the exact opposite as they are on the left. And then we're going to have a wedge, and then we're going to have a dashed wedge. And so here's where it gets a little bit tricky, because you'll find out that as you start drawing in the atoms, you'll notice that there's no way to put the two identical groups completely opposite each other so that they're not adjacent, they're not cis to each other. Because even if we put the chlorine here, it looks identical to the chlorines on the left here. So that would be adjacent. We can't do that. If we put it here, it's also still adjacent to this chlorine on the top. And even if we put it all the way in the back, it's still going to be adjacent to this, this chlorine on the top. So there's actually no way for us to draw this trans isomer in a way that would be different from the cis isomer. So that's unfortunate, but we're going to draw these in, and so it doesn't actually matter where I put any of these three groups, because since we can't draw them trans to each other, they have to be cis to each other, just like the cis isomer. No matter where I put this chlorine, it still makes both of the chlorines adjacent to each other and both of the amine groups adjacent to each other. So this is, while this is kind of just an arbitrary structure, you would be able to rotate any other conformation that you do to look exactly like this one on the right. And so I'm going to get rid of this trans label because we can't do that with a tetrahedral model. So we're going to go back to the original question in number 5, and that's, are these mirror images of each other? And so that's why I did the in-plane atoms this way, so that we don't have to figure out drawing this structure again and slightly rotating things. So we're going to draw in an arbitrary mirror plane here, and we're going to see if all of the groups are matched in their appropriate spaces. So we have the same carbon atom in the center of the tetrahedral, and we have a chlorine on both the two groups that are closest to the mirror plane, and that's exactly mirrored on the right side here. And then on our wedge on the left is an amine group, and same on the right. And then our dashed wedge is also an amine group, and the same thing is reflected on the right. So for question number 5, that would be, yes, these are mirror images of each other. And now we can go on to question number 6, which asks if they're superimposable on each other. And so I'm going to get rid of this mirror plane. And so to do that, rather than having the opposite atoms that are in the plane like we did here for the mirror images, we want to have the same atoms in the plane. And so what we're going to do is we're going to take this molecule on the right, and we're going to, with our left hand, we're going to sort of pinch this chlorine on the top, and then we're going to grab this whole thing and rotate it slightly to the right, which is going to put this chlorine still in the plane of the board, just on the right side. And if we do that, that means that this wedge gets pushed back to be the dashed wedge, and this dashed wedge comes all the way over here and gets pushed in front of the plane to be the full wedge. And so another way of writing that would be, running out of space here, the wedge and the dashed wedge here. And so this is really where those molecular model kits come in handy, so you can see that rotation in 3-dimensional space. But just remember that you never want to break any bonds when you're rotating. So if you have to disconnect your pieces, if you have to break those single tetrahedral bonds, then you're not doing a proper rotation. You're doing some other type of chemistry. So just keep that in mind when you're using your model kits to do these superimposable images. And so we can take this model, and so this is the exact same one on the right, just slightly rotated a little bit. And we can see if we can superimpose it on the model on the left. And what you'll notice is that we have the 2 chlorine groups, those definitely overlap. And then on the wedges and dashes, we have the amine groups. And so these two molecules completely overlap. So for number 6, they would be superimposable. And so that brings us to number 7, which asks, are these two models the same? And the answer to that would be yes, because we can completely overlap them. They look identical. There's no other way to attach the chlorines and amine groups that would give a different structure. And so for question 8, the statement that we can make is that if two molecules are both mirror images and superimposable images to each other, then they're the exact same molecule, which is pretty interesting. So we're just going to bypass question number 9 since we did that in class, and I don't have all of you here virtually to do that anyway. But we are going to make the structures in this little blurb above question number 9. And so I did that in question number 10 here. So I'm just going to zoom in so that we're only looking at one set of those. And so question number 10 asks, consider the two models that have the green balls on the same side. Are they mirror images? Are they superimposable? Are they the same molecule? So the first thing that we're going to address is the mirror imaging. So I have this arbitrary mirror plane right here. And all I've done, these are the same model that has the green ball on the left, just like the instructions said. And we want to see if these are mirror images of each other. So let's start out. We have the white ball on top of the central tetrahedral atom, and that's also reflected on top on the right. So we're off to a good start. And we can also notice that on the dashed bond here, that's the furthest away from the mirror plane, that's the red ball, and that's exactly reflected on the right side as well. However, when we get to the closest atom in the front here, it's the blue ball on the left and the green ball on the right. And there's no way for us to rotate this molecule in space so that these green balls are both closest to the mirror plane, because that would put the red ball in a different orientation and it would no longer be mirrored with the red ball here. So part of our answer to number 10 is that they're not mirror images of each other. So the next part asks if they're superimposable. And so for this part, all I did was take this molecule on the right and just rotated it. And I rotated all 3 of these bonds so that the this red atom sort of went over here in space, but it's still behind the plane of the board. And that caused the green atom to go sort of where the blue one is, and the blue one to go where the red one is. And so I've drawn that here. And the reason that I did that was because it matched up all of the dashed wedges and all of the bold wedges, as well as the in-plane atoms here, because that's what's really important for seeing if things are superimposable. And so while these